Hey folks, this video is a part of video series on C programming. This will cover very basic concepts related to C programming. Starting with the what is a computer program. A computer program is a sequence of instruction for computers to carry out a task for producing a specific results. Programming consists of two distinct steps. First step is about designing. In this step, we provide the solution to a problem in the form of an algorithm, and this is considered as a similar to the work of an architect while designing a building. In second step, we write actual program in a language that we call as a coding, similar to the building construction phase. There are three levels of programming language. First level is the lowest level, that is machine level language. Then comes a next higher level language. We call it as an assembly language. And the highest level of the programming language is high level programming languages. In machine level, this is the lowest level programming language that is corresponding to actual instructions. Those are executed by the processors. And these instructions are simply a series of binary numbers consist of zeros and ones for specific commands like adding two numbers, moving data from one memory location to another memory location. Machine language depends on computer processor, so it is different for different computer processor. The next level higher language is called as assembly language. This is a simple way for humans to interact with computer without remembering the strings of binary numbers. For each machine code, we have simple mnemonics or instructions like add or move. So instead of remembering those numbers, we remember these instructions. Again, assembly language is specific to each computer processor, and they are dependent on the processors. But high level language supports the portability, because here we need not to remember machine level details. These are general purpose languages which supports us to write a complex program without going for the underlying details. There are various high level languages like Pascal, Fortran, Java, Visual Basic, Python, Go, many languages. And generally, one command in high level language may be translated to tens of machine level language instructions, and that's why they are called as a high level language, because these commands are quite high level to support simplicity. But the computers only understands the machine language, so we need to compile or convert the higher level languages into machine level language, like assembly language also assembled or compiled or translated into machine language before executing it. Similarly, for high level language program, we need to translate it into machine level language before we can execute them. For this translation, technically we call it as a compiling of a program into machine level language code. Again, compile is a multi-stage process. It performs in three steps. In first step, we do pre-processing. By pre-processing, basically it modifies the original source code in the memory depending on some commands that we call as a preprocessor directives. These are already written in the source code, so we first perform processing on these. In pre-processing, it also skip the comment sections in the program, and similarly extra spaces and line space are removed from the program. But this doesn't modify the actual source program that we saved on the disk. It just it's in copy in the memory. After pre-processing, actual compilation of program is done by compiler into the second stage, that is generating an object code. But before generating an object code, it checks for syntax errors and warnings. If there is some syntax error, then machine level code will not be generated, and this error will be displayed to user so that the user can correct the error, then they can compile the program. If there is no error, only warnings, then program will be generated, programs executable or machine level code will be generated. And the last stage of compilation is called linking. Here the object code generated by the compiler is linked with the other necessary part like the library code that we used. So it combines with the other dependent object codes to create a single executable file, and this executable file is saved on the system. For a C program, by default on Linux, the executable file is named as a.out. We can change it. Soon we will see how can we change the default name of the executable file. If there is a linking error, then again linker error will be given and no executable will be generated. After these three phases, if everything goes fine, an executable file will be created. Translation can be visualized. See, we can visualize the translation in this form. This is a C program that is now translated maybe in this form. This is a series of zeros and ones. We call it as a binary form. And compiler along with the linker translate the high level program into executable machine code that can be independently executed on a machine. So here the source code is translated into executable code. And C programming language, we call it as a general purpose programming language because it can be used to write different kind of program, and that's why it is called as a general purpose. C language is also called as a middle level language. Why? Soon we will see. C is a structured language. It is a structured programming language because it supports dividing a large problem into smaller functions which handles a specific responsibility. C supports functionality of both high level as well as low level functionality. For high level support functions, it supports portability. It is easy to use the program written for one computer onto different type of computer. Same program can be used, and it also supports some low level functions like binary operators to directly manipulate bits and bytes. That's why C is called middle level language. To write a C program, we used a text editor to create and later modify the program. And C level program written in a file, this file is called as source code. Once the C level source code is written, we can invoke the compiler to convert it into an executable form so that we can run it. In this video, we'll use this program. We compile this program and create its executable file. This is a very simple first program written by Dennis Ritchie in his popular book, The C Programming Language. Quite old program. I will run this program, compile and run this program on Linux using its compiler tool named GCC. Here is the same program, but this is not a correct one. I have added a simple error to show that if there is some error in the program, then it will not be compiled. To compile a program using GCC, just we need to pass program name to GCC. Here it shows that it is expecting a semicolon before the return. Because I removed a semicolon from this line, I have added it again. Now it should compile and a.out file should be created. Now this file is created. I will try to execute it. It's showing me as a name output of this program. We can also change this name by using option O. I can pass the name of a file. This file will be created instead of a.out. Now we got a hello.txt file, and in this way we can compile. And in this step, GCC is doing all three things: pre-processing, compiling, and linking. So it has created, and when in pre-processing, this will perform these instructions. These the program instructions that starting with the hash in C are pre-processing instructions. So since there is no error, it has created executable file. If there is an error, then it shows an error and doesn't create a compilation file. This is all for this video. From the next video, we will go into the further depth of C programming. We will understand each instruction one by one of these programs. Thanks for watching this video.